All right. Hey, everybody. So if you would look at Block 5, Topic 1, Lesson 2, represent proportional relationships. So in your Chapter 5 table of contents, if you would please write proportional representations as your first lesson for that one, and then put today's date on it. So, number 1, a jewelry designer makes a mold for silver pendants in his collection. The graph shows the weight of the silver he needs. How many grams of silver does he need to make 10 pendants? Well, this graph shows a number of points that are darkened little circles right here. And so each of those points means something. So, let me go ahead and just jot down this first point is 1, 2. So to make one pendant, he needs 2 grams of silver. And that actually kind of helps inform us of the unit rate of how much silver he needs for every individual pendant. The next point is 2, 4. The next point is 3, 6. Then 4, 8. And then finally 5, 10. So, be careful. It might be a little bit easy to assume that, hey, 10's here, so 5 is there, so the answer is 5. That's actually not true, because we want to know what number would correspond with 10 pendants. So we got to look at what relationship we see taking every pendant over to every number of silver. So, it's pretty obvious here that the multiplying relationship is 2. For every 1 pendant, you need 2 grams of silver. For every 2 pendants, you need 4 grams of silver, and so on. So, to make 10 pendants, we're going to need 20 grams of silver. In fact, a very simple equation that we could write for this is if the number of pendants is x and the grams of silver is y equals 2 times x. The number of grams of silver that you're going to need is equal to 2 times the number of pendants you're going to make. Let's try that again. Number 2, Zoe, a video game designer, is creating a video game with zombies. The graph shows the time it takes her to sketch the game levels. So how many levels can Zoe sketch in 7 hours? So we've got a few points here. We've got 1, well, that number is kind of between 1 and 2, so I'm just going to go with 1.5. Now, here we just did a little bit of a rough estimate, but it is important to verify that by picking out points that line up with the grid, like this one and this one. We see the next point is 2, 3, and this one up here is 4, 6. Now, these 2 points, because they line up with the grid, there's no guesstimation. I know it's 2, 3, and 4, 6. This one, it does line up with one of the numbers, but not the other. But we were able to say, hey, it's right there in the middle. It's 1, 1.5. Same thing up here, 3, 4.5. Just know that you really don't want to guess unless you have to. But the good thing is that our guess lines up with the 2 values that we were given explicitly. So 1, 1.5, 2, 3, 3, 4.5, and 4, 6. And the process is just multiply by 1.5. Okay, I'm going to level with y'all. Somebody just knocked on my front door, and I completely lost my train of thought on this. So I don't know what the last thing I said was, but what we know now is that if we have the ordered pairs 1, 1.5, 2, 3, 3, 4.5, and 4, 6, the multiplier is 1.5. So multiply by 1.5. And so an equation that represents how many game levels you can design the y value in terms of how many hours you've been working, the x value is y equals 1.5x. The number of levels you can design is equal to 1.5 times the number of hours you've been working. So to solve the problem, if we want to know how many levels she can sketch in 7 hours, just say y equals 1.5 times 7. And then just throw that into the calculator. Comes out to 10.5 levels. Okay, let's work through another one of these. They're giving us a little bit less information. Justin, a hairstylist, is at a styling competition. The graph shows the number of seconds it takes him to braid different lengths of hair. At this rate, what length of hair can Justin braid in 20 seconds? So, it's given us 1 and nothing, and then nothing and 1, and then nothing and 1.5, and then 4, and then nothing. So we got to fill in the blanks. We're going to figure all that out looking at these points. We've got 1, 0.5, and we've got 2, 1, and 3, 1.5, and 4, 2. So 1, 0.5, and 2, 1, and 3, 1.5, and 4, 2. So looking at all these numbers, the process is asking for that multiplicative relationship. And so it's easiest to see with 1, whatever the y value is. The multiplier is just that number. So each of these is multiplied by 0.5. Okay, and so the equation that we'd be working with is y equals 0.5x. The length of hair that Justin can braid is equal to 0.5 times the number of seconds he's got to be braiding that. So the question is, how much can he braid in 20 seconds? Well, plug in a 20 seconds for x. 0.5 times 20, that's just half of 20, is 10. And if you go back up here, 1, 0.5 says that he can braid half an inch of hair for every second. So for 20 seconds, he can braid half of 20, so 10. All right, take a moment, pause the video if you need to be able to work on number 4. Okay, a photographer is enlarging his photo of the Eiffel Tower. The graph shows the corresponding heights and widths of the photo. What is the height of a photo with a width of 15 inches? So we've got this point, which is 1, 4. So that tells me the process is multiplied by 4. Let's see if that continues to check out. The next point is 4, 16. So that would be 4, 16. Yep, that's multiplying by 4. The next one is 728. So 728. And yeah, 7 times 4 is 28. So that's working out pretty good for us. And the last one is 1040. So 10, and yep, 10 times 4 is 40. So, since we keep on multiplying by 4, the equation looks like it would be y equals 4x, or 4 times x. Now, you may notice that I sometimes put the times dot there and sometimes I don't. You don't have to put it. The dot is definitely not necessary. And in fact, once you start working with a lot more algebra, you don't even want the dot there. You're just going to say 4x. Okay? So, now we want to say, hey, what would the height of the photo be if the width is 15 inches? Well, the width of 15 inches is the x value. So, plug in a 15 for x. 4 times 15 is 60. So the height would be 60 inches. Okay, if you would please, let's move on over to the next page. So that would be Block 5, Topic 1, Lesson 3, Interpreting Proportional Relationships. So, we're still working with situations that have a multiplier that relates one value to all the other values. So let's work through number 1. Alan is designing a costume for a play. The graph shows the time it takes him to sew the fabric. What length of fabric can Alan sew in 1.5 minutes? Okay, so to be able to answer this question, we really need some points on this graph, but it doesn't show us the points. So what we have to do, if you remember me talking about this one, we want to pick points that line up perfectly with the grid. We don't want to have to rely on some guesstimations unless we just absolutely have to. So number 1, the first point that I see where these grid lines line up is right here. And then I see another one right here and another one right here. So those points are 1, 40, 2, 80, and 3, 120. And so thankfully I see a little bit of a multiplicative relationship here. 140, 280, and 3, 120. It looks like all of these are just multiplying by 40. So the question is, what length of fabric can Alan sew in 1.5 minutes? So we want to say 1.5 comma what? So all we got to do is continue to multiply by 40. 1.5 times 40 is 60. So I did not mean to just throw my pencil down like that. So the answer is 60. Alan can sew 60 feet of fabric in 1.5 minutes. Now, there's a couple of other ways that you could have gotten this answer, all of which are equally fine. We can sort of kind of see the answer on the graph by guesstimating where 1.5 is on the x-axis, and then scooting our way up to the graph, and saying, hey, that point lines up with 60. Get the same answer. Another way we could have gotten that answer is after making that table, I noticed the multiply by 40 relationship. Well, I could just continue it this way by saying, let's make an equation of y equals 40x. The y value being the length in feet of how much he can sew, and x being the time in minutes. Well, if I want to know 1.5 minutes, that's an x value, so plug it in here. Which of course comes back out to 60 every time. Okay, this next graph, I gotta be honest with you, it's not my favorite because the grid is so small, it's a little bit difficult to see those nice pretty points. So I'm gonna try to push my camera in. Now just know that you might see this pop over to me here for just a second because this camera does not like for me to move it too much. Okay, I am shocked it did not disconnect from my computer. Shocked. I was fully prepared to wave at the camera like, hi. Okay, number 2, Jose, a freelance photographer for a New York newspaper, earns money for photographing professional baseball games. How much does Jose earn in 5.25 hours? See, the thing I don't like about this graph is it's really difficult to tell where it's lining up with the grid. And I think it's because the print of the book is just a tiny, tiny bit off, okay? But those points where it lines up are 190, 2 180, 3 270, 4 360, 5 450, and 6 540. It's meant to line up right there. And I do want to point out that each of these ordered pairs tells a story, okay? If Jose works for 1 hour, he will make $90. If he works for 2 hours, he will make $180. If he works for 3 hours, he'll make $270. If he works for 4 hours, he would earn $360, and so on. So the multiplicative relationship is super easy to see from the ordered pair 1, 90, but you can verify it by just dividing any pay by the number of hours worked. For example, $540 divided by 6 hours of work comes out to $90 per hour. So the multiplier is 90. Again, I am so shocked that that camera did not disconnect. I was fully prepared for it to disconnect because it's done it so many times earlier when I was recording this video, or recording videos tonight. So to make an estimate, honestly, I don't think estimating is super important because we can get the answer pretty easily, but 5.25 hours is the question. So 5 1/4 hours is like right about here. So that would be a little bit above 450. So I just don't know that exact value. So tad bit more than 450, is that an answer? Okay, finding the unit rate. Well, the unit rate goes all the way back to chapter 2, but it's just dividing the y value by the x value. But we can also see it here, 1, 90, the unit rate is $90 per hour. Express the proportional relationship with an equation. Well, all that wants us to do is say y equals 90x. The pay is equal to $90 per hour. If y stands for how much you get paid and x stands for how many hours you've worked, then the equation y equals 90x means how much you get paid is equal to $90 per hour. To solve the problem, we're just going to plug in 5.25 for x. And I am going to plug that into the calculator because I don't know that one off the top of my head. Which comes out to $472.50. $472.50. Okay, my answer is or is not reasonable. Honestly, I don't really want y'all to have to worry about estimations. So, let's go over to the next page and try one more together. Lee, a fashion designer, is making suits for actors at an awards show. The graph shows the cost of the fabric. What is the cost of 4.5 yards of the fabric? So, this graph is a lot easier to see the points that line up. We've got 1, 25. And any of these other points is going to be helpful, but not as helpful as that first point, because that's all I need. That tells me the unit rate is $25 per yard. So the equation would be y equals 25x. So any y value is just 25 times the x value. And here the x value stands for the length of that fabric in yards, and the y value stands for the cost of that fabric. So the cost is equal to $25 per yard. To answer the question for 4.5 yards of fabric, oh, I wrote that backwards. I would have gotten the same answer either way, but it's going to bother me. So y equals 25 times 4.5 comes out to 112.5. So $112.50. Okay, so I want you to try the next one. You do not have to make an estimate. You do not have to answer this about my answer is or is not reasonable, because just figure out the answer. Okay, number 4. An animator is illustrating the character Toby Tornado for a cartoon. The graph shows how fast the character spins. How many times will Toby Tornado spin in 1.9 seconds? So looking at this graph, this is another one that's kind of tricky. I think I see 1, 2.5. So that point is really one of the only ones that feels like it lines up with the grid until I get all the way up here to 2, 2.5. Or excuse me, 2, 5. Well, either way, I see that the multiplier is multiplying by 2.5. And how I got that is, one way I can get that is saying, hey, the number beside 1 is the multiplier. The other way I can say is 5 divided by 2 is 2.5. So the unit rate is 2.5 spins per second, and the equation would be y equals 2.5x. So for 1.9 seconds, plug that in for x. And let me throw that into the calculator. So 2.5 spins per second multiplied by 1.9 seconds comes out to 4.75 spins. We can sort of kind of see that on the graph by looking at just short of 2 would be just over 4.5. But it's much easier to figure that out using an equation. Okay. Let's talk about the exit ticket right quick. I'm just going to use that as an example to set up for the next assignment. So you've got a Delta Math assignment to go on after this. I'm not going to worry about answering this. All I want to do is write the equation for it. So Rachel, a graphic designer, styles letters for a magazine. The graph shows the time it takes her to style letters. How many letters does she style in 4.5 minutes? So I want to write the equation for this line and then just move on with my life. So I can pick any point at all, as long as it lines up with the grid. Now, the easy point to pick is 1, whatever. Here, that is 1, 1.5. That's the easy point to pick because 1, the y value lines up with the grid also. And so I know the equation is y equals 1.5x. And then I could answer the question the book wants me to know. But what if 1 doesn't line up with the grid? What if we've got this horrible point, 1, and we're like, hey, is it 1.6, 1.7, 1.75? Pick any point that lines up with the grid. We can get the same answer. So, like that point. What if that was the only point that for some reason stuck out to me? That is 5, 7.5. We can still get the unit rate from that by saying 7.5 divided by 5 is 1.5. Same thing, okay? To figure out that multiplier, all you have to do is divide the y value by the x value, okay? All right, so please go back to Canvas and check your instructions for the Delta Math assignment. Please put these in your binder at the end of, or really the beginning of Chapter 5, because this is the first couple of pages you're putting in there. And let me know if you have any questions. Y'all have a wonderful day. Bye.